In the previous video, we started talking about the basics of hypothesis testing, including what hypothesis testing is and understanding the null hypothesis. The null hypothesis is the default assumption that we're always trying to reject, and the alternative hypothesis is normally what we're trying to support. We looked at all the different ways that they compare, and now we're ready to talk about some other aspects of the process, including choosing the sampling distribution and the tails of the test and significance. So choosing the sampling distribution means that you need a way of finding probabilities so that you know if an event is significant or not. With claims about population proportions, you'll use the standard normal distribution so that your test statistic would be a z-score and your critical values would be z-scores. If it's a claim about a mean, there's two cases. You could have a known standard deviation from the population. In other words, you're given sigma, then you would use the standard normal distribution. If it's a claim about a mean with sigma unknown, okay, so these are both claims about means, one with sigma known and one with sigma unknown, then you might know the standard deviation of the sample instead. So if you know S, then you'll use the student's t-distribution. Claims about standard deviations can also be tested. We won't get to that in this course, but that would require another distribution, the chi-square distribution. Now let's talk about significance. Significance is where we use the fact that we expect a certain amount of the population's values to fall within a specific range. So whatever the center is, say it's a population proportion, we expect 95% of the time, for instance, that we're going to see most values fall within that range. And so this is what we expect. So if it's very far away, more far away than that, something from the sample proportion falls very far away, we might conclude that that assumed population proportion isn't correct. And so the area that's left over in the tails is what we call the significance level, because those areas under there, if we get a result that has an area smaller than that or equal to or smaller than that, we would conclude that this population parameter may not be quite right. We have left-tailed tests, we have right-tailed tests, and we have two-tailed tests. And recall from the previous video that the symbol in the alternative hypothesis will always determine what kind of tails you have in the test. Now we're going to look at a few examples to try to understand where a left-tailed test might come from. You may have some information that you know or you think or it's commonly believed that the population mean is 16.43. And then you have a sample result that has a sample mean of 16. And so the null hypothesis would be that the population mean is 16.43. But using your sample statistic, you may be looking to see if the population mean is actually less than 16.43. So you'd be testing to see if this result is significant. And if it is, then you would reject the null hypothesis in support of the claim. Or excuse me, I said the wrong word, in support of the alternative. And the reason I wanted to be careful in correcting myself is that the claim does not always have to be in the alternative, although most of the time we expect that we've worded it that way so that we can find support for the claim by rejecting the null hypothesis. It won't always be the case. So using the specific words null hypothesis and alternative hypothesis are very important here. Here's an example with a mean again, but this mean was at 275. That's the population mean that's assumed. And we're looking for enough evidence to reject that in favor of the alternative that the population mean is greater than 275. Well, that would be because we have a sample statistic of 286.2. If that is significantly greater than this mean, we would reject the null hypothesis in support of the alternative. However, Notice that the p-value here is 0.1323. That's the area to the right of the sample statistic. So this sample statistic has a 0.1323 chance of having occurred simply by coincidence or, just as a fluke or whatever. It's too common. And I say it's too common because the general or the most commonly used significance level is 5% or 0.05. And that has to do with the rare event rule and the range rule of thumb and the empirical rule. And we can use other significance levels, and we do, depending on the problem. It'll always be given in the problem what significance level you're being instructed to use. But if we just go on the 0.05, which is most common, this is way too high of a probability. We're looking for something rare in order to reject the null hypothesis. So in this case, we would fail to reject the null hypothesis and therefore fail to support the alternative. Here's another example of a mean where we have the population mean assumed to be 65 and a sample result of 67. And this time the p-value is actually very small and it's less than a 0.05 probability. So in this case, we would reject the null hypothesis in support of the alternative. You can also have two-tailed tests where you're really not concerned about whether it's above or below, but you just want to see if it's significantly different. So in this case, the null might be that the population proportion is 50%, while the alternative could be that the population proportion is not 50%. With a p-value of 0.27425 on one side, that's only half of your p-value, plus this other p-value over here, we're going to have a very high area total, and that's not going to be anywhere near significant enough to reject the null hypothesis. So those are that's really just the overview of how to understand these things, but we're going to get into specific examples where we go through an 8-step process for carrying out a hypothesis test from start to finish. See you over there.